Hi everybody, welcome to the Osprey's Physiology Club meeting today. We'd like to start by introducing our topic of the day. We're going to be discussing transport maximums in regards to the renal system. As defined by medicaldictionary.com, a transport maximum is the maximal rate of secretion and reabsorption of a substance by the renal tubules. This means that transport maximums can be described in regards to substances such as glucose, amino acids, phosphates, sulfates, and organic anions. The transport maximums can be used to describe the secretion rates as well. For this meeting, we're going to look at the reabsorption rates of glucose and the secretion rates of para-aminohyperic acid. The kidneys reabsorb virtually all of glucose within the first 20-30% of the proximal convoluted tubule. So for this reason, most animals, humans included, don't have a problem with glucosuria. So are there any questions yet? Yes, there's a hand in the back.
By glucosuria, do you mean that glucose is present in urine?
Well, of course, yes, that's exactly what glucosuria is.
We can observe the following graph to see how the amount of glucose being filtered, reabsorbed, and excreted changes based on the plasma glucose concentration. Looking at the y-axis, we see that the amount of glucose being filtered, reabsorbed, or excreted increases by milligrams per minute. On the x-axis, we see changes in plasma glucose concentration. We see that as the concentration of plasma glucose increases, so does the amount of glucose being filtered. Also, we see where the transport maximum of glucose is reached, right around 360 milligrams per deciliter. This is the point where no more glucose can be reabsorbed because all the co-transporters in the proximal convoluted tubule are busy. At the transport maximum, we see that glucose concentration continues to increase, as does the amount of glucose being filtered. However, at the transport maximum, glucose begins to be excreted. The glucose must be excreted through the urine at this point so that the body does not have a glucose buildup. Now on the far end of the x-axis, we see that glucose excretion begins to exceed the glucose reabsorption, but this is showing a very extreme scenario. Now let us take a look at the second graph. This graph is showing the para-aminohyperic acid transport maximum. On this graph, we see the x-axis recording the plasma PAH concentration, and we see the y-axis records the amounts of para-aminohyperic acid being filtered, secreted, and excreted. The amount of PAH being excreted is equal to the amount being filtered plus the amount being secreted. To find the transport maximum of PAH, we look at where the amount of PAH secreted plateaus. The reason this is a transport maximum is because the plateau represents the maximal amount of PAH being secreted by the renal tubules.
I have a question. Now that we know about transport maximums, how do we apply them to our daily lives?
Great question. To answer this, we should discuss what happens when glucose is reabsorbed. Since the body needs glucose for many functions, the transport maximum is very high. The glucose begins to be reabsorbed by the proximal convoluted tubule and then activates a sodium-glucose cotransporter in order for the glucose to move out of the proximal tubule and into the renal epithelium cells. After the glucose is in the cell, it can then move to the bloodstream by facilitated diffusion. Once glucose is in the blood, it is then used as energy source by all the cells over the body. To demonstrate the function of a cotransporter, we're going to use 2 hard-boiled eggs and a little egg container. The hard-boiled eggs will be our sodium ion and our glucose molecule. In order for glucose to move into the cell from the plasma, it must be filtered, and then a sodium ion must go to the cotransporter and cause a concentration gradient and allows the glucose to be brought in with the sodium. Now that this cotransporter is filled up, this is at the transport maximum. So if we had another sodium or glucose molecule or ion come in, there's no place for it to go. So you can see that we'll just have a buildup of the ion or the glucose and thus the transport maximum has been reached, and this is when if it's extra glucose, it will have to be excreted out of the body through urine as glucosuria.
In conclusion to today's meeting, I'd like to thank you all for joining us for the Transport Maximums section of the Ospreys Physiology Club this week. Please join us again next week when we have a new topic. We will post on Blackboard what the topic for next week's discussion will be. Thank you.